Now in the last lecture, we have learned how to insert a new node in any given location in CircularDoublyLinkedList. Now in this lecture, we are going to look traversal of CircularDoublyLinkedList. Now here, the idea is the same. So all we have to do, we have to visit all elements of this CircularDoublyLinkedList one by one and print out their values to the console. So first we are going to start from the first node of CircularDoublyLinkedList by using head over here. So when we visit the first node of CircularDoublyLinkedList, in this case, we are going to print out to the console its value. So as you can see, in our case, the value of first node in CircularDoublyLinkedList is 1. Then we are going to continue to the next node. So in the next node, we have 2 over here. So we are going to print out to the console value of 2. Then we are going to continue to the next node. So in the next node, we have 3 over here. So 3 printed out to the console. And then we are continuing to the last node. In this node, we have 4 over here and 4 printed out to the console over here. Now, when we reach the last node, we are going to stop over here. This means that our traversal is finished. Now, as you remember, when we are creating CircularDoublyLinkedList, we have set size property in our CircularDoublyLinkedList class. So this means that by using this size property, we will identify when we reach the last node in CircularDoublyLinkedList. Because if we don't identify it like this, otherwise it might continue to the infinite loop, because from the last node we have reference to the first node, so it might go to the first node again and continue to traverse through the nodes one more time. So by using size of the CircularDoublyLinkedList, when we reach the last node, we are going to stop over here. Now let's see how the algorithm of this traversal is look like. So the algorithm is very simple. So first we are checking that if head exists or not. So if head is not equal to null, this means that our CircularDoublyLinkedList exists. Otherwise, it means that it does not exist. So we are going to terminate our algorithm over here. So if it is exists, we are going to continue to the loop through the head to tail. And in each iteration, we are going to print out to the console the value of node. Now, if the current node is equal to tail, we are going to stop over here, or we can use the size property of CircularDoublyLinkedList and stop when we reach the last element in the CircularDoublyLinkedList. So until we reach the last node, we are going to repeat the process of printing values of nodes to the console. Now, based on this algorithm, let's implement traversal method in practice and see how this is working. Now here, inside CircularDoublyLinkedList class, after insertion method, I'm going to create traversal method over here. Now the name of this method will be traverse CircularDoublyLinkedList. So I'm going to declare it like this. Traverse CircularDoublyLinkedList. So it's obvious that it's not going to take any parameter, because in this case we are going to visit all elements of the CircularDoublyLinkedList. So according to our algorithm, the first thing that we are going to do, we are going to check head value. So if head is not equal to null, in this case it means that our CircularDoublyLinkedList exists, so we can continue to loop through this CircularDoublyLinkedList over here. Now, as you remember, we have mentioned that we are going to use head to identify the first node. So that's why I'm going to create doubly node over here, which we'll call temp node, and I'm going to assign head value to it, because in this case we are going to start from the first node, so that's why I have to assign the head value over here. Then by using the size property of the CircularDoublyLinkedList that we have declared over here, we are going to loop through the all elements of CircularDoublyLinkedList. So our loop will start from I is equal to 0. It will continue until the size of CircularDoublyLinkedList. So here I am putting I less than size, because we are starting from 0. That's why we are putting not equal signs over here. We are putting only less sign. Then I going to increase by 1 in each iteration. Then in each iteration, we are going to print out the values of temp node to the console. So I'm going to put print temp node dot value. Then to make our code more readable, I'm going to write if condition like this. So if I is not equal to size minus 1, if this means that we have not reached the last node, then in this case, we are going to print out arrow between the nodes. So I'm going to print out arrows like this. So with this, we are putting arrow between the nodes. So this makes our code more readable. Then outside of this if condition, I'm going to continue to the next node. So by setting temp node's next reference to temp node, we are continuing to next node, because in the next reference of the temp node we have next node's physical location, so that's why I'm putting it like this. Then in the else condition, if it is equal to head, it means that our CircularDoublyLinkedList does not exist, so I'm going to print out to the console saying that CircularDoublyLinkedList does not exist. Now at the end, I'm going to just put over here one more print statement to make one more time our output more readable. Then with this we have completed our method. Basically what we are doing over here is we are just visiting each and every element of CircularDoublyLinkedList and print out their values to the console. Now let's see how this is working in practice. Now inside this main class we have created our CircularDoublyLinkedList like this, and we have inserted 3 more nodes to this CircularDoublyLinkedList. Now here when we are creating it, we have initially the value of 1 in our CircularDoublyLinkedList. Then we have inserted 2 at the first location, then we have inserted 3, then we have inserted 4 over here. Now if you run our code, you see that it's printing out CircularDoublyLinkedList like this. Now here our first node is 2, then the second node is 1, then the third node is 3, then the fourth node is 5. So as you see, it's printed out our CircularLinkedList the way that we have inserted the nodes in our CircularDoublyLinkedList. So everything works the way that we want. Now let's see what's the time and space complexity for traversal of CircularDoublyLinkedList. Now as always, we are going to start from the first line of this method. Now in the first line, we are checking head reference if it is not equal to null or not. So this if condition will take O1 time complexity. Then in the next line of code, we are creating a temporal node and assigning head value to it. And this one also will take O1 time complexity. Then when it comes to this loop over here, it will take On time complexity because we are looping through the all nodes until we reach the size of CircularDoublyLinkedList. So if the number of elements in the CircularDoublyLinkedList is n, so the size of CircularDoublyLinkedList will be n. So that's why the time complexity for this loop will be On. Now inside this loop, we are printing out to the console the value of each node, and then we have if condition like this in which we are printing out arrows between the node's value. So this part of code also will take O1 time complexity. Then when it comes to this line of code over here, we are just setting next node of temp to the temp node. So this one also will take O1 time complexity. Then we continue to the else condition. So in the else condition, we are printing out to the console this message over here, which says the CircularDoublyLinkedList does not exist. So printing out message to the console takes O1 time complexity. Then when it comes to the last line of this method, here just we are calling the print function. So this will take also O1 time complexity. Now if you combine all these complexities over here, it's obvious that we will get On time complexity. Now the space complexity is O1 because in this case, while we are looping through the CircularDoublyLinkedList, an extra memory is not required. So space complexity will be O1. Now with this, we have come to the end of this lecture. So in this lecture, we have learned how can we traverse through the CircularDoublyLinkedList, and then we have created it in practice, and then we have learned what's the time and space complexity for this method over here. So hopefully everything is clear about this method. So see you in the next lecture.